Hello, I am back. This time, hopefully, I'm going to remember to change screens at the appropriate point. Echo. Okay, that is gone. Alright, so, as a reminder, this project is all about this thing. This is an Acorn A3000, circa 1990-ish. This was a home computer in the UK, one of the first to be based on the ARM processor, the ARM2, which was the first commercially available one. It ran this proprietary operating system called RISC OS, which was considered pretty advanced at the time. So the goal here is to have a full emulation of one of these machines in a web browser. So to facilitate that, I decided to write it in Rust, which will compile to WebAssembly. Haven't figured that bit out yet, so at the moment I'm writing it as a native application. So where we're at the moment, let's see, we have basic emulation of a CPU. It just takes the ROM image and starts executing it one instruction at a time, and it keeps going until it hits something that I have not implemented yet, and that gives me an idea of where to go next. It does some weird stuff. Starts off from the reset vector at the 0 location, and that jumps into the actual code, and then that has this weird pattern that it goes through, which I assume is some kind of memory test based on the moving 1 bit. Then it does the same but inverted. It doesn't execute any of this because it has the never condition, which is this F at the beginning, on all of those instructions. And eventually it gets to yeah, you can't see that. There we go. Gets to here, which is the first real instruction. Loads whatever the program counter points to into register 0, and then it tries to do an ALU instruction, which is one of these things. Got the addition, subtraction, bitwise operators, comparisons, all that funky stuff. So last time I implemented the skeleton of those instructions. Where is that? Somewhere here. Oh yeah. So right now they're all jumping to a unimplemented function, which just, that's what does this panic. So the first one I'm going to implement is the one it says it's got here, which is opcode 4, and opcode 4 is add. So add should be pretty easy. Add 2 numbers. So I've already gone through the nasty process of extracting all this stuff. Where's the diagram that tells me this? So yeah, all this stuff here. You got various operands encoded into the instruction word, and sometimes that can be an immediate, sometimes that can come out of a register, and always it can go through the barrel shifter, which shifts it left or right or rotates it right. So that means you can have an 8-bit value that can be used across the whole 32-bit range as long as the 8 bits are together. Okay, so the addition is just op1 plus op2. Okay, sorry, I already did that in there. Does that mean that's going to work? Good grief. Alright, so to make this easier for my debugging, I'm going to need to do a format thing for this. This is what it outputs at the moment, which is not terribly useful. So I'm going to have to replicate some of this to figure out which instruction it is. So let's copy this. That gives us our opcode. And we're going to need a array. So how do we do an array? Const ALU ops. And we need to give it a type because it's a constant. By the way, I've been learning Rust for like less than a week, so I'm going to make tons of mistakes here. So what do I need? A str or a string? Guess we'll find out. So 16 of those. Alright, looking alright so far. So let me put them in. They are and EOR, sad donkey, sub RSB, that's reverse subtract, add with carry, subtract with carry, reverse subtract with carry, I assume, test equivalence or something like that, compare negated, or because it had to be 3 letters, move bic, that's bit clear, not a biro, and mvn, which is move inverted, and it does not like that. Okay, there's supposed to be references to strings. Gotcha. Alright, so let's stringify that. So we go ALU ops, use that as an index, but we have to cast it to, what is it called, usize. No, what's wrong here? Expected string found. What? What? What is going on? Ah, forgot my as. There we go. So I got that as a usize. Pants for birds. My Rust through is hot garbage. I need to buckle down and really learn it. If you looked at it at all, you probably already know more than me about it. I've done plenty of C and C++, but Rust has some weird stuff going on with memory borrows and all that safety stuff. But it does have some really useful things for writing an emulator, like you can do an add and it'll tell you whether the add overflowed. Yeah, pattern matching is cool. I haven't looked too much into what other functional features it's got, which means I'm probably not doing that well enough. Alright, so we've got our opcode as a string. So that will be there. Let's see, opcode. Is this actually executable yet? Aha, there we go. There's no condition code at the end because if it's, what is it called? AL, always. If it's that, it just doesn't print it because that's the way you would do it if you were writing the assembly. So what else do we need? Destination register. No, this is IntelliJ with the Rust plugin. Alright. Register number, register destination. Alright, let's take that. So that is going to be R and that. So that's RD. So some of these things like RD would normally be horrible names for variables, but it's the domain language, so I reckon it's okay here. Yeah, I've never been a big Vim fan. I used to use Emacs back in the day, and then went through various other console editors. Then when I had a C++ job, I used to do a lot of Visual Studio, which was the best IDE around at the time. This was like 2001. After that, like TextMate, Sublime, and then on to IntelliJ, which is the one piece of software that I use enough it's actually worth paying for. Alright, add R15. I wonder if it's 15, we should change it to PC. Using Emacs with Vim bindings just seems wrong somehow. So we got that. First operand register, so RN. That's going to be pretty simple. You know, I'm going to put a to-do on here. To-do change to PC if it's 15. Yeah. Do that later. So RN. So how does it look? I think it's a comma, and then that. Okay, add R15, R0, and then the next bit is where it gets really complicated. Can be a literal number, it can be a register. Either of those can be shifted, and they can be shifted by a literal number or a register. So I think I'm going to have to take a big chunk of this code. So I'll take it all and then I'll cut it down a bit. Okay, so what is our result of this going to be? It's going to have to be the string. That'll be the easiest way to do it because it can be so many things. So let up to equals, if it's an immediate, then what does that look like in assembly? Let's take a look at the documentation again. It's a long time since I've written any actual ARM code. Alright, examples, here we go. I want an example of shifting an immediate. That is not there. Alright, no problem. I'll just do it how I think it should be. So we take our value, we take the amount that we're going to rotate, which has to be a multiple of 2 because it actually stores half of that value. So we've got the value, we've got the rotate, so I guess we return format. What is that going to look like? That, then the value. See, if you don't rotate it, it shouldn't say anything. So I should have rotate nothing. Okay. So we should say if rotate is greater than 0, then we return, what is it going to look like? ROR followed by the amount. Otherwise it's going to be nothing, right? Okay, so value and rotate text. Oh, no, what is it not like? What? Why is it complaining about that? Ah, okay. Yeah, that's stuff I don't even need yet. Let me... Okay, I'm going to have to work through that. There's nothing I can comment out immediately. So, if it's not an immediate, then RM is the second operand register. Okay, I need that. Unshifted is the... What is it? That is a good question. We're in here somewhere. So we've done the immediate. So now we're doing this section. Oh, hi Susie. Could you make a function with match that you could reuse for that? Probably. Once I do this and look at which bits are similar, I might factor out some of that. VLSI Technology is the, they're a chip fab company, and they made the original ARM chips. They built the ARM chip and the 3 controllers that went with it, memory controller, vid controller, and IO controller. So eventually I'm going to have to emulate all of those to get a working system. So this is from a book that they published in the 90s, and they would send out for free to anyone who asked. And mine went missing somehow. I managed to find a copy online eventually after I remembered what it was called. So what are we doing here? So we know operand 2 is in a register. So we know what RM is. This is just an expansion of that. Okay, so we got the register, and then we got the shift amount. Okay, so this is gonna give us a register and a shift amount. So R squigglies RM. Nope, not that, because we're returning it. That bugs me. To return something, you don't put a semicolon on the end. Don't like that. Should just always return the last thing, and it gets thrown away if you don't use it. So this is going to give the register, but I also need the shifty stuff. So I don't need the actual value from the register. The shift type I do need. The shift amount I do need. Okay, so this bit here says the shift amount can also come from a register. Just to make things complicated. So this is tell me whether it comes from a register. So if it's that, then I'm going to have to format it as just the register, right? RS. So I don't need the value from it. Is that right? yeah, that's, so I call this just shift. So if it's an immediate, then again that's going to be that. Like that. So that is the, did I call that shift amount before? Because that probably is what it should be. Because it's not the whole shift. It's got the shift type, might as well move that down here. So now these are just going to return strings instead. So that is logical shift left. This is that's casting it to a signed, so it's, wait, why is I32 signed? Why isn't it S? So is that an arithmetic shift right? Because it extends the sign bit, and then this is a logical shift right, and then this one is a rotate right. So actually, I think I'll take that, stick that in there, and put that in there. So now, okay. So I only do the shift stuff if the shift amount, oh, my shift amount is a, oh God. You know what, I'm just gonna put it in anyway. So shift type and shift amount. So sometimes it'll be 0. Shift type, shift amount. How's that look? Errors, unexpected token. 133. Oh, is that special? I think that's part of the formatting stuff. No. What is that trying to tell me? No, come on. What is it telling me? Expected one of dot, semicolon, question mark, or an operator. That's weird. Oh, it's this. Stupid missing semicolon. Okay, what are we on here? 123. Expected struct string. Let rotate text. What? Is this because these are returning different things? Yes, so, okay. I would have to cast this to string, is that right? Aha, 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 aha. Okay. Balls. That is only giving me my... Get out of here. My Stream Deck buttons don't work properly. What's up with that? Yeah. Something's missing. Ah, right. I gotta put it in here as well. Op2 that I just did. There we go. Oh, okay. So take R15, sorry, take R0, add 15 to it and put that in R0. Alright, that's kind of working then. So let's put that in the jump table. 0, 1, 2, 3, 4. Exec ALU add. Oh, that's not what we want. Very much not what we want. So what happened there? I have to stop it earlier. Wow, that is fast. Oh, it's too fast. Put it through less. Okay, so what happened? This is all our never stuff. Oh, right. Hold on. So adding to R15, so it should have jumped. Did it jump? Oh yeah, it did. So we used the program counter as the destination, so it jumped to... Right, we know from before that this will have loaded 0 into R0. This would have put 15. 0 plus 15. That doesn't look right. Why would you add 15? Am I missing a times by 2 somewhere? There was something in the documentation about this. Here, so for the immediate, write rotate amount to be applied to 8-bit immediate 2-bit shift units. What does that mean? 2-bit shift units, doesn't that just mean I multiply by 2? So I take that immediate, those 8 bits, where is it? I'm multiplying that by 2. Maybe I'm just doing it wrong in my format. No, multiplying by 2 there. Wait a minute. Wait a goddamn minute. How can I multiply by 2 and get 15? That's not right. So this is the immediate bit. So if immediate, do this bit. The rotate value is that nibble. Wait, hold on. No, it's not the immediate that is multiplying by 2. So I must have had 0 in the rotate value. 8, 9, 10, 11. So in my code, I'm taking that bit, shifting it down, taking 4 bits of it. That looks okay. According to the docs, multiplying it by 2. So it must be 0. I can look in the word. So 0f is the immediate, so that's 15. And yeah, the rotate is 0. So multiplying that by 2 is still 0. So 15 is right. So what's going on there? Add R15, R0, 15. That's adding 15 to the program counter. I wonder if that's supposed to set the status bits. So the program counter actually looks like this. Yep, messed that up. What the heck? Come back. Okay, so the program counter looks like this. You have 26 bits of address. Then at the bottom you got the mode flags. And at the top you got the status bits. So what is 15? That is all these ones set. 1, 2, 3, 4. So it could be adding, you know, even if it's setting the mode bits, it's still adding 3. This doesn't make sense. Oh yeah, you can add 3, and that's actually adding 12. Right, because it's 26 bits of address, but only 24 are stored here. And the bottom 2 for the actual program counter are assumed to be 0. So it could be jumping 12 ahead and setting the mode bits. So what do the mode bits start as? Oh wait, we're not adding 2 R15. We're using R15 as the destination, so 0 plus 15. So essentially we're just setting PC to 15. So we're setting, so then it's doing the right thing, because we jump to here, which is location 15, because these are in hex. Wait, no, this is location 16. That is correct, right? So 1, 2, 4, 8, yeah. So if I put an F in there, that's what is it? It's not location 16. What would it be? So we've got 1, 1, 1, 1, but 2 of them are for that. So it's 1, 1, 0, 0. So shouldn't that be location 12? But also, this is not ROM. If we go to the memory controller docs, this is the memory layout. So, alright, this is a little bit weird. What happens initially is that the ROM is mapped down here at 0 address, because that's where the processor starts running. But if you retrieve something from there, and then you retrieve something from where the ROM really is, it unmaps that. So, say something about this here. Where does it say that? Ah, effective reset. Here we go. When the reset line is taken high, memc initializes the following state: memory map. Processor starts executing code from location 0 to ensure that the processor always finds valid code. memc continually enables ROM. To restore the normal memory map, the processor must first perform a memory access with the address lines A25 and A24 both low. So memory access to 0 to retrieve the reset vector will do that. And then a memory access with line A25 high. So that's anything above. So this is for, so anything above here, I think. Right, that sounds right. Because if 4 is the highest, or one more than the highest, then halfway is going to be 2. So anything from here upwards will have the top bit set. These conditions are satisfied when the processor starts executing instructions from location 0 and later jumps into the normal ROM space. Okay, so at this point there is no ROM in 0 page. So what is going on? Why is this happening? And why is it so dark? Why am I so dark? There's too many lights. Hey Google, turn off the office reading light.
Okay, turning off the office reading light.
That is not any better. Get some reflection going on. Barely helps. Okay, shouldn't have used a dark mode. So what could be going wrong here? Maybe R0 is supposed to be something else. I thought it was loading nothing. Huh. Alright, so 294. That is our offset. Do I still have my OD? Yes. What did I say it was? 294 is where we load from R15. 294. So that's here. Yep, that looks right. So when we load from R15, R15 is 2 words ahead of where we're executing because of the 3-stage pipeline. Got execute, decode, fetch. The other way around, obviously. So when we're here, R15 is actually this. So we load what R15 is pointing to. That's what the square brackets are. And put that into R0. So R0 is empty. And why doesn't it just move a literal 0 into... This might still be part of the self-test that it's doing. Let me just check what happens when you have R15 as a destination. Definitely says this somewhere. I saw it before. R15 as an operand. Pretty sure I fixed this though, so I did the right thing. In RM position, it gives the value with the flags. RN or RS without the flags. Okay. PC value will be added to the address of the instruction plus 8 or 12 bytes due to instruction prefetching. 8 8 or 12. If the shift amount is specified in the instruction, the PC will be 8 bytes ahead. If a register is used, the PC will be 8 bytes ahead when used as RS and 12 bytes ahead when used as RN or RM. Oh my god! Oh, what? Alright. Okay. The PC value will be the address of the instruction plus 8 or 12 due to instruction prefetching. If the shift amount is specified in the instruction, PC will be 8 bytes ahead. PC is the amount specified in the instruction. The PC will be 8 bytes ahead. So where's my execute add? No, what am I doing? Execute ALU. So where do I do this? Is this the shifting bit? No. Shift amount. Yeah, so here. Okay, so I always keep my program counter 8 bytes ahead of the instruction that's been executed. So when I fetch an instruction, I take account of that and I subtract 8. So it's kind of emulating the pipeline without really having it there, because we're not going to do a fetch, a decode, and an execute at the same time. So in this part, when it's RS, so in this part, oh, it's immediate. Oh, the shift is immediate. If the shift amount is specified in the instruction, the PC will be 8 bytes ahead. Okay, but if the shift amount is specified in the instruction, then it doesn't matter what the PC is. If a register is used, that means this bit. Oh, I'm not even on my code. If a register is used, that means this bit here. The PC will 8 bytes ahead when used as RS, 12 bytes ahead when used as RN or RM. Ah. That's some tricky business. So that means I can't do this here because it might be different depending on which one of these we're in. Good Lord. So I'm going to have to return the shift amount and this thing. Oh man. So I can say what RM is, but when I get it from the register, if it's register 15, I gotta add another 4 to it. Is that right? Yeah, that's right. Oh, okay. So I'm going to have to do if shift amount and unshifted. So here return shift amount and, ooh, this is getting hairy. And that, but wait, hold on. Oh, I need a name for that variable. It's hard to name them when they're all so abstract. I'm going to call that value from reg equals hang on, what am I doing there? If it's, oh yeah, so I'm going to take that and yes, I'll do if, oh, don't need those. If rm equals 15, then add 4, otherwise just do that. No, I got a better way. Keep that in there. And I'll say let PC offset equal if rm equals 15, then 4 else 0. And then here I'll just do that plus the PC offset. So that's giving me that. I need to do the same here then. So is this the one where it gets weird? So this is where the shift is from a register, RS, 12 bytes ahead when used as RN or RM. Oh, we gotta do up 1 as well. My God. So we're gonna have to do that. Gonna have to return all of these bloody things. Where can I put that? What does it look like? Wait, so 8 bytes ahead when used as RS. Ah, hold on. What am I doing here? The shift amount. So it's used as RS here. So RN and RM. I have to kind of invert the logic of what they're saying. So RN and RM need to come from here. Well, not RN and RM exactly. It's which is the bit that I just removed. When we dereference them to get the actual value, then we need to add 4 to the value if we are in there. Alright, let me think about that. So when it says RN, I'm really talking about op 1. That means op 1 does have to come out of here. Okay. This gets a little tricky because if that goes there, that means I got to return op 1 and op 2. So in this case, it'll just be normality. Whatever normality is anymore, I don't know. Get rid of that. And then, what is it saying about op 1? So we're adding an extra 4 if we're in here. So that means oh man, I'm getting lost in this. This is returning shift amount and unshifted, which we use here, and return that. So that was up 2. So now let's assume that we're going to return op 1, op 2. Can shadow variables like that? Seems a little sketchy. So op 2 comes out of there. So what is Rn? Let's go back to this documentation. To heck. So Rn is always a register. So Rm is when we're shifting. So it's the second operand before the shift, which is actually what it says here. Okay. So when we dereference that, where were we doing that before? Were we doing that before? Did I miss a whole thing where I didn't actually dereference that? Oh no, I do it here. There it is. So I'm calling that unshifted. Okay. So take whatever is in that, which means that. So we're doing that here. Does that mean I'm covered for that one? Okay. So the Rn, where do I do that? That's here. Op 1, op 2. So here returning op 2, op 1. So it needs to be different in here. Shift amount unshifted. think I just need to add another thing in here. What do I call it? Because it's not RN, because that's the register number. It's up 1, isn't it? So now returning 3 things. But it seems necessary. So when I get to here, oh, I'm only returning 1 thing there. That was never right then. Is that what I had there before? This thing's supposed to tell me. Just tells me that I added stuff. Great, that's useful. No, go away. What does this side do? Ah, oops, no, wait, what? Oh, confused. That's not telling me anything useful, is it? Oh, I thought I'd get a diff out of that. Can I do that? Oh, no. Compare with same repository version. Okay. Oh, I added all this stuff. Ooh, that's gonna be a big commit. Oh well. Shift amount, unshifted. Okay, well I know at least that in this case, the first one needs to be that. Just got to deal with this thing now. So we've got to return the shift amount and is it still running? Get out of there. God damn it. So if it's RS, it's always, oh, lost my page. So RS, it's always 8 bytes ahead, so I don't have to do anything to that. If it is RN, which is what's giving us up 1, so this is returning the shift amount, because that's what we get from dereferencing RS. That's what the S is, the shift. So the unshifted value, where does that come from? RS, shift type. Oh. Hold on. Where's the unshifted amount? So the shift amount. Try and figure out this documentation. I have to rewrite some of this so I actually understand it. So this is my RS. So I'm shifting 4, 5, 6, 7, 8. That's where I shift that down. So that's getting that. Okay, cool. Dereference it. That gives me the actual shift amount. If it's not a register, then it's that. Unshifted. Aha. So the unshifted bit is going to be this regardless. Oops. So now I just need my op1. So if it is okay, so it's always 8 bytes ahead there. So does that even compile? So that gives us up 1, that gives us up 2. Let's see what happens. Probably goes nuts again. No, probably doesn't compile. Not found in this scope. 89 PC offset. Okay, so we don't have that because it doesn't do that if it's a register. Alright, I'm fine with that. But we're still stuck in our madness. Utter madness. Get rid of that stuff. Cargo run. Let's see what happens. So we get to here again, and it just does the same thing. God damn it. Hold on a second. Hold on, what is this? We print out ALU opcode, we're not putting out a new line. So it's actually jumping to 12. That makes sense. Because I had F, which is 1111. Bottom two are implicitly 0 for an address, so it's 1100, which is 8 plus 4, which is 12. Seems to be doing the right thing. You know, I am gonna decode this bloody thing by hand, because only that way will I know I am not going completely crazy. All right, go away, webcam. Go away. Don't want you. Why don't my buttons work? Stupid thing. Oops. There we go. Alright, so I'm going to write it all down. So what is it going to look like? From the documentation. So what do we got? We got E090, E090, foof, foof, that's the instruction, E090 F00F, That is the one in question. So if we break that down, that is a condition of always. So that bit is always. So then the 9. Hold on. 9 is. Let me write this out in binary. That's going to be easier. So E is 1 less than F. So 1 1 1 0. I'm going to put nibble boundaries in. And 0 0 0 0. We've got 9, which is 8 plus 1. We've got 0 again. We've got F, which is 1 1 1 1. 0 0 0 0 0 0 0 0 and 1 1 1 1. Yeah. Like a prisoner counting days on the wall. Right, so let's decode it. So, you know what? Let's change color. Just for the sake of it. Right, so this is always 0 0 1. Oh wait, what? Oh, 0 0 I. That caught me out before as well. So 0 0 means it's a ALU instruction. This means up 2 is a register. Up 2 is a register. And then the opcode is in a weird place. It's these 4 bits. So 0 1 0 0, that's 4. So that is add. I'm not going crazy there. And then S is 1, so that is set condition codes. Alright. I've actually completely ignored that so far. Hopefully that's not the issue. So the first operand register, Rn, is this. Destination register here, so that's so Rn equals R0, Rd equals R15. Jeez, I can't write. Okay, so all of this is operand 2. So we got to break that down. So depending on this I we had earlier, where's I? Opcode 2 is a register. So that means we have Rn. Oh, really? Oh, shit. Wait, I was using... Oh, I think I've used that as an immediate. And it should have been the register number. So Rm equals R15. And I've just used 15 instead of register 15. Oh, what an idiot. So stupid! And then the rest is a shift field, so that's all 0. So shift equals 0. So it doesn't matter what that is, because it's whatever kind of shift it is, it's doing it by nothing. But it happens to be an immediate shift amount. The shift type of whatever. Right, so that is my problem. So essentially what this is doing is, and this is so important, it's time for a new color. Add with an S, because it sets the status bits. PC destination RN R0 PC. Right. So it's saying PC equals PC plus 0. But dun dun dun, PC is already PC plus 8 or 12, depending on the phase of the moon and such things. So we're doing either PC plus 8 or PC plus 12. So we're jumping 2 instructions ahead or 3 instructions ahead. Yes, that almost seems to make sense. So I wonder what I'd actually get if I went there. So this is, wait. 298, that's right. So it's saying to jump to either here or here. Interesting. Very interesting. So presumably if it jumped to here, it would be doing another load. You know what? I bet it is, because you go load, add, and that jumps, load, add. That kind of makes sense. Don't know where that's going to take us. Some merry ride. So where am I getting that wrong? Do RM here, and then where do I use RM? Here, here, here and here. This seems too much RM now. Why? Up 1 is R what? RN. That should be here, surely. Such madness. Wait, oh, hold on. Ugh. Yeah, can't do that. I'm going to split these up to make it clear. Nice and clear. Alright, same with this one. So I can't use the same offset, because I have to check it for each one. So I'm going to take that and stick it there, and then I'm going to stick another one here, but it's RN. So get rid of that. Yeah, Bob's your uncle, I think. We haven't actually changed anything. So it's still going in the wrong place. Presumably. Come on. Yeah, still going to the wrong place. So, at some point, I'm not dereferencing RM properly. Oh, wait, what? No, that's right. If it's immediate, we go here. If it's from a register, we go here. So RM is the bottom 4 bits. That is correct. So we've got the shift amount, the unshifted, so the unshifted is that. Feels like that should have no flags though. What does it say about PSR flags? In the documentation. R15 as an operand. Oh, we're in multiply now. R15 as an operand. If it's used as an operand, blah, 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 blah. It's contain the value of the PC. It may or may not contain the values of the PS. Okay. When it appears in the RM position, it will give the value of a PC together with the PSR flags. Right. I think that's okay because then it sets it without, doesn't it? No, it sets them with. Ah, crikey. Oh look, there's that syntax I was looking for. So RN and RS. It ain't got it. That's suspicious. No, we do that there. We do use that. An RN. That should also be no flags. But in the RM position, gives it together with the PSR flags. But does PSR include the processor mode? There's something that will tell us that right here. Where is it? Where is it? Where do you go? Get back here. Okay, R14. La 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 la. What? All right. Contains the program counter and the processor status register. Okay, so I think the mode bits are part of the PSR. So when we dereference RM, we're going to include those. That seems suspicious. Got 1 in there. We should check what it says about PC as a destination register. Does it say that? Writing to R15, there we go. When RD is registered on R15, when RD is R15 and the S flag in the instruction is set, the PSR is overwritten by the corresponding bits in the ALU result. Alright, so that's the upper bits. In user mode, the other flags, IF, MI, MO. What? What are they? Ah, okay. Interrupts, fast interrupts, and the mode bits. Are protected from direct change, but in non-user modes, which we must be in because we just started up, these will also be affected, accepting copies of bit 27, 26, 1 and 0 of the result respectively. When one of these instructions is used to change processor mode, the following instruction should not access a banked register, blah 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 blah. If edge register is clear, only the address bits will be written. Okay. RS bit was set, wasn't it? Yes, it was. It certainly was. So, get back to where we were. What happened? Did I miss it? So what is it doing? It's loading from... Alright, but it's not going to be that F anymore because we're going to dereference it. So, maybe if I go back to the paper, figure out where it should be jumping to. So we got adds PC R0 PC. Okay. So which PC are we going to be using out of all that crazy complexity? Instruction 1 4. Oh my god. Why do I do this? Can't even find my thing anymore. Here we go. So what was this testing? Ah, whether RS comes from there. Okay. Wait, so does it for us? Not 1, 2, 3, 4. Is 0. So we're not using RS, so we're in here. So we will be adding the extra 4. Oh. I was sure we would not be. So we're going to be doing PC plus equals 12, which means we're here and go 4, 8, 12. We're going to end up here. It's skipping over that. Doesn't seem right. Does not seem right. Where's that thing I was reading earlier? If the shift amount is specified in the instruction, the PC will be 8 bytes ahead. Oh. Yeah. That's what we're doing, isn't it? We're in here. No, we're not, are we? Up to is a register. So we are in here. Wait, hold on. Right way around. Do I actually invert it? Other than my brain at this point. Okay. Oh, right. Looking at the wrong one. Oh my god, I'm getting so lost in here. Okay. Bits 4 to 11 are all 0, so that means it is a literal, so we're not in the registry bit. Wait, so we are doing the plus thing, and we should not be, right? Because that says, where was it? Right. So I got these in the wrong place. They need to go up to here and up to here. Yes. Alright. Doesn't fix the problem, but at least it will jump to the right place when it jumps. Which so far is still not, right? Let's have a look. Yeah. So we still got that weirdness where we're using 15 instead of R15. So where is that happening? So that is up to. So we do the shifting here. So at this point, the unshifted should already have come from a register. So it comes from here. and that is dereferenced and dereferenced. I'm going to print these out. What should we do? Up 1 equals blah blah blah. Up 2 equals other blah. Just put that there. So it still returns, and that needs a semicolon. And that doesn't print. Did I save that? I'm sure I saved it. What the heck? Oh, wait a minute. Does that mean I'm in the if immediate bit? Where's my I? I shouldn't be in the if immediate bit. I should be in the up to is a register bit. So how am I calculating immediate? I'm saying if bit 25 is a 1, should that be bit 25? Let's see what it says. Yeah, bit 25. If it's a 1, it's an immediate value. Wait, so that means this is doing what it's supposed to do? Taking that literal 15. Wait, but I got 0 in there. So it should be a register. Immediate equal that being 1. I don't think I'm in the wrong place, but just to be sure. What? How am I getting in there? It's immediate if bit 25 is not 0. That's what it says. Can we print that out as well then? So we'll call it instruction 25. Immediate bit 112. Oh, hold on. I didn't mask it. I have to mask it with 1. Yeah. This only works without the mask if you're comparing it with 0, doesn't it? Oh, whatever. It's clearly wrong. Where did I get to? I'm lost again. Here we go, new instruction. Aha! That is better, but not right. Okay, so now instead of the immediate, we're doing... That's a big number. Why is that a big number? So in my format, I need to change that to... see, now it's all groovy. Should move my webcam. Oh, not that. How do I move that back? There we go. Stick that up there. It's more like it. So it's now decoding it right as well. So I can get rid of this, and I can get rid of... Yeah, but why is up 2 so big? Where is that coming from? Up 2 is... Oh yeah, it's whatever the program counter is. So if I print that out in... Don't remember how to print in hex. How do I print in hex? Hex anywhere? Hex, hex, hex. I've done it before with the CPU. Oh yeah, there it is. This business here. I bet that'll be the same as the program counter. That and that. Yeah. But we add those together, assign them to the program counter, and it doesn't jump to the right place. Why is that? We are just adding them together. Setting the destination register. Aren't we? Ah, God, no. This is awful. So that means sometimes it's going to be 8 ahead and sometimes 12. Because what I do is I store the where do I execute? I store the PC before I execute the instruction. Execute the instruction, and then if the program counter has changed, so if it's the same when it comes out, it just increments by 4, so it goes to the next instruction. If it hasn't, if it has changed, that means something is written to the PC, either loading it in or branching or whatever. But it means that the PC contains the new address that we need to jump to. So normally what that would do is flush the pipeline. We don't have a pipeline, so we have to simulate that. Why are we adding 8? Why are we adding 8? Why are we adding 8? so we don't increment to go to the next instruction, but we do add 8, right, because we always expect the PC to contain 2 instructions ahead, so that when we get back to our fetch again, we're fetching the right one when we subtract 8. So in the real CPU, what would happen is the pipeline would be flushed, the instruction would be fetched, decoded, and then executed. So by the time the next one gets executed, again the program counter is 2 instructions ahead, because it's decoding and fetching the 2 instructions after the place we jumped to. So that seems right. So why doesn't it do that? Interesting. Very interesting. So what did we have? 298. So adding 4 to that would give us 29C anyway, wouldn't it? 8, 9, 10, 11, 12. C is 12. So does that mean we ended up in here? Let's call that normal increment. And let's call this flushed pipeline. Oh, it's a bit messy now. So it's normal increment every time. Whoa. Okay, so let's print these out. What am I going to call it? PC before and PC after. So that'll be PC before and this thing. That is our PC afterwards. And let's make those hexy. Yeah. Oops. Let's get hexy, baby. Alright. Let's see what that does. Apart from make a big splurgy mess. Okay. So execute that instruction. So the PC before. Oh, what? Huh. That's interesting. That's quite fucked up. Because I'm always keeping the program counter 8 bytes ahead. If an instruction changes it to be 8 bytes ahead, we don't recognize it as having changed because it's the same going in and coming out. So should I be... Let's see... So if it's 8 ahead going in, then if I don't touch it, it's going to be 8 ahead coming out, which means go to the next instruction. But if I change it to be 8 ahead, then it's still the same coming out, so it'll still just go to the next instruction. So what can I do to differentiate that? The only thing I can think of is How do I do this? Is there a way I can compare them? So there's 8 going in. I mean, 8 ahead coming out is entirely reasonable. So my options are, if I set the program counter, I have to set it to 8 more than it should be. But that is getting the logic in just the wrong place. Because then my register file, which is supposed to be a fairly simple independent thing, now has knowledge of my pipeline simulation. It's not really good. So maybe I should do something more like what the real CPU would do, which is explicitly flush it. Because when I execute, I pass in the I don't pass in the CPU anymore. I used to pass in the CPU. But Rust complained at me for having both mutable and immutable references. So how am I going to do that? You know what? I started doing something before. Where is it? Instructions. Did I remove it? I did remove it. Duh. I had an enum of like what to do next. So enum action. So the actions would be continue or flush. So now I define all of my execs. Define all of those to return an action. And change my type here so that returns an action. Everything goes back to being good. Yeah. Take that off the end. Boom. So I just got to change my functions now so that they... Oh, hello. Expected action found, not yet. That's because my instruction handlers, these also need to return an action. Okay. So when we execute a branch, of course we're going to return flush. Do I have to qualify that as our action? That now needs a semicolon. Okay, cool. First one done. Load store. Let's get rid of some of these. Oh. This is going to have to be if RD equals Oh, no parentheses, I always forget that. Var equals 15, then we return flush. Oh, action flush. Action flush. Sounds like a super powerful toilet. Otherwise, action continue. All right. Unimplemented returns whatever that unimplemented returns. What is this? So this is the actual load register, store register thing. So presumably we get a destination register somewhere. SD reg? That must be it. Alright, but only if it's a load. If we're storing it, that doesn't matter. We don't flush then. So if is load and SD reg equals 15 action flush, else action continue. All right, and then yeah, we did that for the add, so that'll just get, oh, hold on, no, it's format. Yeah, so that'll just get returned here. So then our CPU should now be a little bit unhappy. If we don't execute the instruction, it should just be a continue, right? So let action equal that, else action continue. What? It's private, so we need to. Oh, right. We got to put a pub in front of that enum. Cool. So now we don't need to bother with PC before. Don't need to test this. In fact, it's an enum, we can just match on it. So yeah, let PC increment equal match action. So can what, do we do case or not? I can't remember. No, looks like not. Action continue is 4. Why isn't it like that? Do my match wrong? No. Maybe it's just because I haven't done this yet. Move these around. Put that there and that there. There we go. So still don't like those. Why? Why is it expecting an empty tuple of all things? Okay, well, that didn't help. And yet it has inferred the type properly, I think. Let's compile it. Maybe we'll get a better error. No, same error. Oh wait, hold on. What? Action equal. That is why, you tricky little bugger. Okay, so now, hey, that's the right one. It's doing the right thing. Amazing. Unbelievable. Can't believe it happened. Just a little bit of JavaScript in there. Oops. Alright, that looks like a good place for a commit. Implement add instruction. What should we say about this? AL instructions are dispatched by a jump table based on opcode. You're supposed to do these to 80 characters, aren't you? Doesn't even tell me how many characters I'm at. What a jip. Instructions. Now return an action that tells the CPU whether to continue or, oh, is that my 80 character mark? Whether to continue or simulate flushing the pipeline. Yeah. You know what? To continue or simulate flushing the pipeline. There we go. Commit and push. Cool. How long has that been? Over 2 hours. Wow. Alright, I am done for today. So next time I am gonna add the status flag updating to those ALU instructions. That'll be a little bit tedious, but fairly easy. Alright, so goodbye.